2008, before lithium ion batteries got really big for transportation. Somebody at the Department of Energy came to me and said, "Are we running out of lithium?" There was a man in France who was publishing sort of Chicken Little papers. "Oh my God, we're running out of lithium. We're not going to be able to make all these batteries." And so the question was, are we running out of lithium? And the answer was, no, we're not running out of lithium, but cobalt and nickel could be kind of problematic. And obviously, if you want to try to use the materials most efficiently, you've got to include the recycling. And so we started looking at recycling, and it became very clear that the methods of recycling that were being used commercially were not really optimal. They didn't get the best back out of the material. You know, if you can reuse something as it is, obviously, then you don't have to redo all of the steps from making it from scratch. And if you can reuse part of it, you can do pretty well. And what we figured out about the battery recycling technologies was that the most primitive one was just throwing it into a furnace and getting some of the metals out the bottom. It worked, and you could do anything you wanted with the metal when you got it back, but it lost the lithium and it lost the aluminum and it lost anything organic. And so that was not a very efficient way to recycle the batteries. The next way is to chop them up and dissolve everything in acid. And then you've got all of those different ion solution, and you can get them back, and you can not start from scratch, but start from pretty early in the battery manufacturing process and rebuild everything that you needed. And that was sort of the most advanced thing that was on the market. But there was a couple of researchers that were looking at ways that you recover the components of the battery, in particular the cathode material, which is a really complicated, nice crystal structure. And they were looking at how you could recover that crystal structure intact and reuse it. And we finally convinced the Department of Energy that that was a really cool thing to do. And so they started the ReCell Center for Battery Research in 2019. And that's ongoing at Argonne and the other national labs with some university collaborators. So all of that experimental work got started. But there were still concerns about material. And the work that I've been doing has been more on the material supply side. And so what we were doing was estimating, looking at people's projections of how many batteries were going to get used and how many cars, that kind of thing. And what we determined was, nickel and cobalt are still going to be kind of scarce here. And in fact, if you look at the projections by Platts and S&P and various Roskill kinds of companies, what you see is that everybody is forecasting a shortfall on the battery materials. And so the question that I was asking next was, well, how much can recycling do to solve that problem? And unfortunately, the answer that we came up with is not rocket science. It's pretty obvious. The growth is so rapid and the product lasts so long that it's going to be a really long time before the recycling makes a big dent in the material we need. And in fact, it's not until demand flattens out that you can actually get what the desired circular economy, which is the big buzzword these days. So we, sort of proved that we were still going to need new raw materials until growth stops. So that brings up a whole set of other questions, which is, well, if we don't have enough of these materials, what other materials can we use? We're very interested in other battery chemistries like lithium sulfur, lithium air, solid state batteries, sodium ion. If you follow the news, you'll see a new plant that's being built based on some variant on the chemistry every day. And then the other half of that is, well, and also maybe you can use less material per person, per car. per mile. So for instance, the big push in the United States has always been bigger is better. That for some reason, that's the American thing. And it's perhaps somewhat misguided. I mean, if you think about how much of the time are you actually using your car? Most of the time it's just sitting in the garage. And so maybe you could do with a smaller battery. You don't necessarily need to have a 500-mile range on your car. If you only go 50 miles a day, maybe you only need 50 or 70 miles of range in your battery. And so instead of tying up a very large amount of material that you're not using very efficiently, maybe we should all have plug-in hybrid cars, or maybe we should be looking at in-road charging for cars that have smaller batteries. And obviously there are whole sets of mass transit sorts of options that are way more efficient with the materials that we've got. That's sort of where my head is now. And I'm about to do a study to understand, given a fixed amount of material, should we put it into one battery electric vehicle, or should we put it into 6 plug-in hybrids, or should we put it into 50 or whatever the number ends up being pure hybrids? And then the question is, what is it you're trying to maximize? Do you want to maximize the number of miles you get per ton of material? Do you want to minimize the amount of CO2 that's emitted? Just what is it your objective is? And that's a question that most people don't bother to answer, which makes it kind of hard to figure out what the right path is. So that's where my head is.
Yeah, I totally understand that. When you're looking at the engineering and the science from this macro perspective, it's definitely not always clear what path you want to take, because you got to take into consideration consumer habits, just what do people value, how do you engineer different things for different uses, and you don't necessarily know how these things are going to be used all the time, right? So yeah, I can definitely see how that's always going to be a challenge, and all you can do is kind of give information to help people make better decisions, right? And give them some baseline knowledge to help them understand the impact of their choices in consuming, I suppose. So yeah, that's great. That's what I want to do here, is try and get some real base level understanding, even get down to the physics and the chemistry a little bit, so they understand things like energy and power and density and efficiency and all these things, right? Just so that people who are looking at maybe selecting an EV, that they kind of understand the advantages, the disadvantages, just have some intuition of what's going on at a really, really fundamental level. So actually that's a good place to move to compare it to gasoline in terms of power and energy, because that's a big thing with batteries, right? The point of having a battery is to have some mobile source of energy with you. And gasoline has been, at least for cars, has been that source of energy for a long time. And batteries have a pretty heavy lift in order to replace gasoline, right? Because gasoline,
right, and that's been the big problem. I mean, really, they haven't been nearly good enough. The big advance that the lithium-ion battery made over something like nickel metal hydride or worse, lead acid, was that you could store a lot more energy in a smaller volume, with a smaller mass. I mean, there were electric cars in the past, and there were cars with lead acid batteries in 1908 or something. But it didn't go very far, and it didn't go very fast, and it had a big heavy battery. And that in fact is the same thing that happened with the impact in the early 90s. It was essentially a battery on wheels, and it was cute, and I drove one, and you could drive it fast, but not very long. But the invention of the lithium ion battery enabled a much, much more compact battery. So instead of being so there could be room for more stuff on the car, and the huge breakthrough really was enabling stuff to get really portable. And the first mobile phones were like shoebox size, right? You don't want to, now you put the thing in your pocket. That's a huge difference.
Yeah, so electronics have gotten smaller, but the battery is the driving force for a lot of our portable electronics and our.
Well, yeah, I mean, it's not just the battery, it's all the rest of the circuitry is also miniature.
Mhm.
I mean, you know, I remember when I was a kid, we had a TV that had tubes in it. And now there are all these
Sure.
little teeny tiny printed circuits, right? That miniaturization enabled all sorts of devices that we never even imagined, right?
So it seems that batteries have just recently crossed that threshold for being usable, like really practical in electric cars, but they're still really heavy and bulky, and they come with disadvantages of range and things like that. But I also want to talk about the advantages of using electric energy for cars versus versus gasoline. What's the benefit besides just our goal of using less fossil fuels and things like that? But there are some innate advantages of electricity as well, right?
Certainly electric cars are handle way better. They can be charged anywhere. I mean, you can charge it in your house, which is an advantage and a disadvantage because energy justice is a big deal now, and not everybody's got their own garage. So that's a disadvantage in the sense that it's not as level a playing field. It's giving an advantage to richer people, really. So
And
that's one of the reasons why the Biden administration is so hot on public charging and charging for multifamily dwellings and various ways to try to make that, to keep the playing field more level.
it's like a total reimagining of the infrastructure, right? Because our whole fueling station has been based around gas for so long, and we had gas stations, but electricity, we have the grid, and the electricity is like everywhere now. So it really like makes sense to rethink how we can distribute these charging centers. I think it's going to take some creativity, some policy.
Yeah, and I have really mixed feelings about that because if you want to get the EVs in the market, home charging and workplace charging get you something like 80% of the way there. It certainly gets you started, but it's not entirely equitable because you do need public charging for people who can't do home or workplace charging.
And then to stick with that charging a little bit, I want to talk about efficiency as well. So one of the benefits of using electricity to power cars is that it's actually more efficient than the gasoline, just in terms of like energy conversion, right?
Mhm.
So like
Right.
just the way we take a stored electricity in a battery, even though the vehicle overall is heavier, just the conversion of stored electrical energy in the form of a battery and converting that into kinetic energy is better than
Right.
the thermodynamic process that we go through of burning the fuel and.
Right. Although it depends on where your electricity comes from, obviously.
Okay,
I
sure.
mean, you know, if the electricity came from burning coal, you're sort of back where you started from because you lost a factor of 3 in the first place, right?
Okay.
In going from the fuel to the electricity. But if you're using renewable fuel or nuclear, then it is way more efficient.
Okay. Yeah, I always wondered how those conversion works because you're going through the whole energy supply chain now, right? So
Right. And then
so
that's what, you know, what all the life cycle analysis does. And in particular, there's an Argonne GREET model that has in great detail information about how all of the steps that the fuels go through until they get to the end of your powertrain in your car. That's been studied kind of in huge detail. And they do that also for any biofuel as well, because at this point, if you use something like ethanol from corn for your car, it's still transported. If it's not going through a pipeline, it's going to go in a truck, and the truck is probably using diesel. So even biofuels as delivered today are using some fossil fuels. And that's actually a discussion that I keep having with the people who are doing the fuel studies is, why don't you look at the case where the truck is also biofueled?
yeah, okay. So that's something I haven't studied a whole lot. I've been interested. It's hard to figure out on your own. People talk about like the electric cars don't matter that much if you're burning coal or burning oil or natural gas to get your electricity.
They're still better, but the grid is getting greener.
Okay. Yeah. So what does that conversion look like in terms? So if I were to burn some hydrocarbon at a power plant at some efficiency and then transmit the electricity to my house wherever I charge it, and then so what does that efficiency look like versus like just the transportation of the fuel and like just using a fuel in my car? Do you have that comparison? Or
Basically, if you're using biofuel or if you're using electricity, you're doing way better than you would if you were just using fossil fuels.
Yeah.
But ideally, and at some level, you would be not using any fossil fuel along the whole supply chain. People are finally getting to that. There have been a number of big government initiatives announced very recently about decarbonization of industry. That's what that's all about. Industries like the fashion industry have suddenly become aware that when they get raw materials, they have environmental impacts that were produced in making those fabrics or whatever. And so you'll hear a lot of industry conferences about the green economy or circular this and that. And they're talking about scope 1, scope 2, scope 3 emissions as this is something they just invented or thought up. And that's just what we've been doing for literally 50 years. Really looking at the entire life cycle of whatever it is.
So it sounds like regardless of the fuel, the source of electricity, just using electricity and the distribution system that we have in the form of power grid, that electricity is still just a more efficient way to go than burning fuel in your car. Is that right? At least a little better.
Yeah. Even if you look at a horrible case like the state of West Virginia, you're still doing better on the electric car. If you have an electric car and compare it to an ICE, it takes more energy, more resources to make the car in the first place. The battery is resource intensive to make, but you quickly pay back that deficit like 20, 30, 40, depending on your assumptions, 1,000 miles of travel. The battery does replace some of the internal combustion parts, but it's big and heavy, as you pointed out, and it takes energy to make the thing and a lot of material. And that's back to my point of, well, you don't really need that big a battery. So if you can charge your car in the garage overnight, maybe you don't need a battery that will take you more than 50 miles. And if you've got a plug-in hybrid, then you can go on your long trip anyway. Or maybe you can do something revolutionary like what we did when we took our younger kid to college. We rented a van because we couldn't fit all our stuff in our subcompact cars. But we did that once in 20 years.
No, I'm totally with you there. Yeah, you really have to take consumer habits into consideration, but also I feel like especially Americans have gotten used to just the flexibility of having a giant vehicle powered by gas that can go anywhere, long distance. People plan for the use in those edge cases that maybe we just need to find some better way of supplying those services when they need it versus have that available to everyone all the time, because that's really expensive actually, right?
We have to be really careful when we're suggesting more economical ways of dealing with transport, because I don't want to come out suggesting something that's going to be inconvenient for people. The question is whether the same services can be supplied in a more efficient way.
Perfect. Yeah. Can we move on to the materials in the battery itself? Because I know you focus on the supply chain. We talked a little bit about the recycling part. Let's talk about the materials in there and the lithium, and then, like you said, at the very beginning, the nickel and the cobalt are the big ticket items with that. But it sounds like they're finding alternatives to that. So could you just explain the process of I guess, first of all, why lithium is so important, why that's so valuable in the battery itself, and then what we're doing to get these other materials and try to innovate in order to take advantage of, I guess, of the different materials and the different possibilities for using lithium as a battery.
You're starting to get to sort of the material properties and why they work in the battery. And that to me is sort of mysterious, really. Lithium has a huge advantage in being sort of the lightest solid element there is. And so if you can get it to do stuff for you, you're going to be able to do it without having a lot of mass. On the other hand, if you're thinking of substituting the lithium with something else that has 2 electrons, one of the things people are looking at is whether there are ions that they can use, like magnesium, that have 2 charges that they can be sending back and forth. And so for every atom, you would then have twice as many electrons that could move back and forth and therefore have a higher power battery. So that's one kind of different element that people are looking at. But why different elements behave differently in batteries is, I think, a complicated set of properties that I am not expert in. I can tell you that there are lots and lots of different configurations of elements that are being looked at for batteries, and they all have advantages and disadvantages. There's a whole set that are more energy dense that would enable even smaller batteries than the lithium ion. And none of those has proven to be quite as robust yet. One obvious thing that people are doing is using lithium as the anode, as well as using lithium salts as the cathode. And that makes a much more energy dense battery than using carbon and silicon as the anode material. But there have been problems with dendrites where the lithium sort of grows and short circuits the battery. So the life of those batteries hasn't been sufficient. So there are all kinds of technical issues with the various improved performance batteries, and the battery chemists are working, sort of round the clock trying to fix all of those problems.
Yeah, it's a multifaceted problem and depends on the application, right? Because you want
Right.
power, you want efficiency, you want density, but you also want cheap.
Right. But on the other hand, if what you're doing is a stationary storage application, you really don't care how much the thing weighs.
Sure.
So that's a whole other set of parameters that you have to worry about. Something like lithium iron phosphate as the cathode material is way safer and doesn't use scarce materials. And we've got iron up the gazoo. There's lots of phosphorus. So we could actually be making lithium iron phosphate cathode material domestically. There have been some announcements that we are going to be doing it, but that's a less energy dense battery. And so if you want a high performance car that's going to take you 500 miles, maybe you want to have a current technology battery instead of a lithium iron phosphate battery. But the LFP battery might be much cheaper and still allow you to go, 100 miles a day or whatever number it turns out to be. Depending on what your user needs, some of the alternative chemistries could really be valuable.
Yeah, that would be interesting, because I know for electric cars, like the battery really is a big expense still in there, and they're pretty bare bones besides the battery, right? Electric motors are cheap and easy to manufacture.
Yeah, they really are. That is the big deal in the car. And there are also, a lot of sort of clever ideas people have come up with where you can have a standardized modular shaped battery, and for all of your daily needs, you use your low performance battery. But if you're going on a long trip, you go to the rental place and you rent a higher power module to, so you can go on the highway for 200 miles or whatever it happens to be. But there are, novel ideas people are discussing for how to use material more efficiently.
Yeah,
I mean,
I
one is
remember.
battery swapping, and I don't know whether that's gonna, that has huge disadvantages in the
Okay.
sense that it's got to you want and when you want it, and you're not going to be you're not going to come up with a system where you've got spare batteries at every gas station.
Okay.
The capital investment and the material investment in that is just out of sight. That's why Better Place went belly up really fast.
Okay. I was optimistic at the beginning when the electric cars were first coming to market. I thought that might be a possibility for charging, would be just the battery swap.
It works for buses in China where there's a central location and the buses are standardized. There are a couple of specific, I mean, it's a perfectly good idea. If you have all of the batteries the same and concentrated in a single location, and the company owns them. I mean, if you have your own battery, you're not going to go swap it out for somebody else's old crap battery, right?
Right. Yeah, no, fair enough.
But it
Okay.
also works for electric bicycles because it's small and you can do it yourself, and you can have a vending machine for that, like propane tanks.
Okay. So what does the degradation of the batteries look like? Like, because cycling them is part of what causes them to degrade, right? Is it
Right.
just using them makes them degrade, or is it time, or I'm sure it's
Yes,
a
both.
combination of a few things. So
It's
what drives it, and then how basically what does the longevity look like, and then what do we do at the end of that?
one answer to that is we don't even really know yet because so few batteries have really gotten to the end of their life. One thing we discovered was that the Nissan Leafs that sat out in the sun in Arizona went to hell fast. So temperature is obviously an important factor. The other thing that they're working on is fast charging degrades batteries. They just don't last as long as if you charge them really fast. So battery life depends on things like whether you discharge it fully and charge it fully. If you treat your battery well, it will last way longer than if you abuse it.
So should you keep it mostly charged for the lithium ions anyway? Should you keep it mostly charged most of the time, or is it bad to just let it sit in your garage at mid charge or low charge?
Depending on the chemistry, they recommend, between 10 and 90% or 20 and 80,
That's a
but
big
fully
range, though.
charging and fully discharging are not so great for your battery. And you've now gotten to the end of my knowledge on that one.
Okay, fair enough.
I know it matters.
Uh-huh. And the temperature you mentioned, I know that's a big part of the battery management systems, right? Is the cooling system and the temperature regulation. They put a lot of work into that for
Yeah, and
performance.
apparently if it's really cold, it doesn't do it. I don't know whether it actually affects the lifetime, but it's certainly that everybody knows that your range is lower if you're driving at really low temperatures. Actually, for clean cities, I've been looking at understanding the problems people have had with charging and stuff. Because if you're going to try to convince people to buy a car, they need to know that it's that it's going to work in cold weather, for instance. And there are a bunch of horror stories about chargers not really working very well when it's cold. And there was one story that was circulating about a guy who had a Tesla, and before you can charge the battery, you've got to warm up the battery. And he was at this charging station for, an hour, and his battery wouldn't even warm up, let alone charge. It's an issue that needs to get addressed. And I mean, I think it's soluble, but the battery lifetime depends on how well you treat the thing. And the reason we don't have a lot of the data is because they're lasting really well, which is
What
why
is that?
Second Life works. Why batteries are available after your car dies.
Yeah, okay. We could go to there. So what does that look like if the second use of the battery, if it's not good enough to use in your car anymore, but it still holds maybe say half the charge or something, like that's still pretty good. Like so what kind of uses are people finding for those batteries then?
Oh, things like backup for some computer system needs to have a battery, or energy storage for your house or for a data center. There's a stadium in Amsterdam that's powered entirely with used Nissan Leaf batteries. There are tour boats in, I think, Sweden that are using Second Life batteries to power these local boats. I mean, there are all kinds of things you can do. There's always the question of how long it's going to last thereafter. And so a big field is trying to understand how to characterize state of health of batteries after they're used. One reason that we don't have very good data on end of life batteries is so many of them are actually getting exported. And so we don't have the data in the US. And that's in fact an issue that I'm concerned about, is we're losing a lot of material that we imported in the first place.
So what's the time scale look like for this? So years, decades?
The Tesla batteries appear to be lasting well more than 10 years. And again, that's just something that depends on the chemistry. So LFP batteries last longer than NMC batteries. So we really don't have any data on how long the batteries are going to last. Typical thinking is sort of 10 years in the car and then 5 or 10 years doing something else. But that's one of the reasons why recycling is not going to be supplying all of the raw material for a while, because the batteries are still in use. They're not coming back.
Mhm. So that the plan for recycling and that whole process, that's a decades long project until it eventually levels
Well,
off.
the reason the recycling industry is actually burgeoning in the US at this point, but not because of end of life batteries, but because of manufacturing scrap. All of the new battery manufacturing plants are producing scrap material and batteries that don't work that well and so they go straight back to recycling. And that's enabling the recycling industry to get built up.
Okay, let's close out here. I know you said you weren't a fortune teller, but I want to ask you, there must be some projections about battery use in the future, consumer trends. I read that like electric vehicles are going to be half of the produced cars in, at least in America, for in like maybe 10 years or something. Is that sound right, or is that what you have no idea? Okay, these are just people saying things.
It's physically possible to have a situation where all of the new cars are electric by X year. But in order to do that, we're going to need to be more efficient, or we need to get the material from somewhere, or else it's going to be really expensive. You must have seen all the projections that show shortfalls in cobalt and nickel and also lithium. Lithium is less problematic in the sense that it's more widely distributed. The US actually has some. You can get it from seawater if you have to. But nickel and cobalt, the US does not have, and the Chinese are pretty much controlling the market. And not
Okay.
only that, if you don't pay any attention to international factors, just looking at how fast you can bring these plants online, there's not going to be enough material available,
I see.
regardless of who owns it.
So it's not going to be a future with the technology that we have today. It's the batteries, the lithium batteries we have now are not going to take over the industry. It's going to be some modified.
I think something's got to give. If you were an economist, you might say, oh, well, the prices will just go up. But that's clearly not something that we want to happen, especially since we're looking towards trying to have a more equitable society.
Okay, and certainly if we don't do things like public transportation or something like that, coupled with the push towards electrification, then it's gonna have some issues then. That's pretty good for my questions. Do you have anything else you want to talk about? Maybe some specific projects you're working on, or maybe some field of interest that you think is like really worth pushing the research towards? Like what's kind of a hot topic that you see that has real potential if it was invested in terms of money and time?
On the recycling side, I'm really hot on thinking about robotic disassembly and design for recycling. I mean, right now, all of the different battery packs and modules and cells are different sizes and shapes and different variants on the chemistry. If you want to take it apart for repair or reusing part of it or recycling, you've got to pretty much have to do it manually or else just shred the whole thing.
Mhm.
And that's totally inelegant. And a buddy of mine at the University of Birmingham in England has a saying basically, which is shredding a battery is like taking a Victoria sponge cake, putting it in a blender, and then expecting to be able to recover the cream.
It sounds particularly messy to me to recycle them, especially with the heavy metals
Right,
and stuff.
and the analogy is really excellent because the materials in a cell are all layered just the way the Victoria sponge cake is. And so the idea is if you could recover stuff layer by layer and actually get it separated, and then you could reuse the pieces. But the way the batteries are designed now, they're all different. It's way too labor intensive to imagine separating stuff manually, but it's
Mhm.
just a perfect job for a robot if it's designed in such a way that you can take it apart. So I think that's a big stumbling block to efficient recycling.
Okay.
And I don't want to downplay recycling. In the long term, it's absolutely going to be necessary.
Yeah. So you're thinking way ahead with that kind of stuff. That makes
Well,
sense.
and on some products, obviously, it's a day-to-day thing. It just the batteries are so damn good that they're not going to come back for a while.
Okay, that's a pretty optimistic vision for me. I mean, at least balance with some of the problems with materials and things. But okay, I think that's a pretty good view of where things stand, where the supply chain is, the materials. I don't have any other questions. That was great.